Section 01. Welcome to our new course, Python TensorFlow Programming with Coding Exercises. In this section, you will learn about Introduction to TensorFlow. In this introductory section, we'll cover the basics of TensorFlow, one of the most powerful tools for machine learning and deep learning. Here's what to expect. Article. This section includes an article discussing Introduction to TensorFlow, featuring detailed explanations and examples. Please read the article carefully to understand the core concepts and functionality of TensorFlow. If you have any questions or encounter any confusion, don't hesitate to message me directly. Assignment. Topic: Install TensorFlow and run a basic program. Details: for this assignment, you will install TensorFlow in your development environment and run a simple program to ensure everything is set up correctly. The assignment includes detailed instructions and solution hints. After completing the assignment, you can submit it to me for review. Coding exercises. Install TensorFlow in your environment, follow the steps to install TensorFlow and verify that it's correctly set up. Import TensorFlow and verify installation. Write code to import TensorFlow and check that the installation was successful. Create and run a basic TensorFlow session. Learn how to create a TensorFlow session and run it to perform operations. Define constants and variables in TensorFlow. Practice defining constants and variables within TensorFlow. Perform simple mathematical operations with TensorFlow. Execute basic mathematical operations using TensorFlow functions. Use TensorFlow to perform basic matrix operations. Apply TensorFlow to perform matrix operations and understand its matrix manipulation capabilities. Watch the video provided, where you will find detailed solutions, algorithms, and the skills required for each of these coding exercises. After completing this section, you will be able to install TensorFlow and set up your programming environment. Import TensorFlow and verify that it's working properly. Create and run basic TensorFlow sessions to perform operations. Define and use constants and variables within TensorFlow. Perform basic mathematical and matrix operations using TensorFlow functions. If you have any questions, confusion, or issues, please feel free to message me. I'm here to assist you and ensure you have a smooth learning experience. Section 01. Problem 01. Problem statement. Set up TensorFlow in your local development environment. Skills required. Basic package management skills with pip or conda. Instructions. Choose a package manager, pip or conda. Execute the installation command in your command line interface. Algorithm. Open command line interface. Run installation command. How code is working. These commands download TensorFlow from the package repositories and install it in your environment. Pip install TensorFlow fetches the latest version from PyPI, while conda install C conda forge TensorFlow installs it from the conda forge channel. Problem 02. Problem statement. Verify TensorFlow installation by importing it and checking its version. Skills required. Basic Python programming and familiarity with Python libraries. Instructions. Write a Python script to import TensorFlow. Print the TensorFlow version to verify the installation. Algorithm. Import TensorFlow. Print TensorFlow version. How code is working. The code imports TensorFlow and prints its version. This confirms that TensorFlow is installed correctly and allows you to see the installed version. Problem 03. Problem statement. Create and execute a basic TensorFlow session to understand TensorFlow's computation management. Skills required. Understanding of TensorFlow's session management. Instructions. Define a computation graph. Run the computation in a TensorFlow session. Algorithm. Define computation graph. Create and run session. Print results. How code is working. The code defines a simple computation, addition of two constants, and runs it in a TensorFlow session. The result is computed and printed, showing how TensorFlow executes operations in its computation graph. Problem 04. Problem statement. Define and initialize constants and variables in TensorFlow and understand their roles. Skills required: basic TensorFlow programming and understanding of data structures. Instructions. Define constants and variables. Initialize and print their values. Algorithm. Define constant and variable. Initialize variable. Print values. How code is working: the code defines a constant and a variable, initializes the variable, and prints their values. Constants hold fixed values, while variables are intended to be updated. Initialization is required for variables to set their initial state. Problem 05. Problem statement. Use TensorFlow to perform basic mathematical operations such as addition, subtraction, multiplication, and division. Skills required: basic understanding of TensorFlow operations and arithmetic. Instructions. Define mathematical operations. Run and print results. Algorithm. Define operations. Create and run session. Print results. How code is working: the code defines basic arithmetic operations using TensorFlow functions and executes them within a session. The results of addition, subtraction, multiplication, and division are computed and printed. Problem 06. Problem statement. Perform basic matrix operations such as addition, subtraction, and multiplication using TensorFlow. Skills required: understanding of matrix operations and TensorFlow's matrix manipulation functions. Instructions. Create matrices. Perform matrix operations and print results. Algorithm. Define matrices. Perform matrix operations. Create and run session. Print results. How code is working: matrices are defined as TensorFlow constants, and basic matrix operations, addition, subtraction, multiplication, are performed. The results of these operations are computed and printed using TensorFlow sessions. Section 02. Welcome to our new course, Python TensorFlow Programming with Coding Exercises. In this section, you will learn about TensorFlow core concepts. In this section, we will dive into the fundamental building blocks of TensorFlow and understand its core concepts. Here's what you will cover. Article. This section includes an article discussing TensorFlow core concepts, featuring in-depth explanations and practical examples. Make sure to read through the article to grasp these essential concepts. If you have any questions or face any confusion, feel free to message me directly for clarification. Assignment. Topic: build a simple computation graph. Details: in this assignment, you will construct a basic computation graph using TensorFlow. The assignment includes detailed instructions and hints to guide you through the process. Once completed, you can submit your work to me for review. Coding exercises. Define tensors and explore their properties. Learn how to create tensors and understand their attributes and functions. Create variables and assign values. Practice defining variables and assigning values within TensorFlow. Build a computational graph with multiple operations. Construct a computation graph that includes several TensorFlow operations. Execute the graph in a session. Run the computation graph within a TensorFlow session to perform the defined operations. Explore placeholders and feed data into the graph. Understand how to use placeholders to feed data into the computation graph. Save and restore TensorFlow models. Learn how to save a trained model and restore it for future use. You will find a video detailing each coding exercise, including solutions, algorithms, and the skills required. After completing this section, you will be able to define and manipulate tensors, exploring their properties. Create and assign values to TensorFlow variables. Build and execute a computation graph with multiple operations. Use placeholders to feed data into the graph. Save and restore TensorFlow models for persistent use. If you have any questions, confusion, or problems, please don't hesitate to reach out to me. I'm here to help and ensure you have a successful learning experience. Section 02. Problem 01. Problem statement. Define various types of tensors in TensorFlow and explore their properties, such as shape, type, and dimensions. Skills required: basic TensorFlow knowledge and understanding of tensor properties. Instructions. Define different tensors. Explore and print their properties. Algorithm. Import TensorFlow. Define tensors with different shapes and data types. Print properties like shape, type, and dimensions. How code is working: the code defines tensors of various shapes and data types. Tensor properties like shape and type are retrieved and printed using TensorFlow sessions. This demonstrates how to handle and inspect tensors in TensorFlow. Problem 02. Problem statement. Create TensorFlow variables, assign initial values to them, and explore their properties. Skills required: basic TensorFlow programming and understanding of variables. Instructions. Create TensorFlow variables. Assign values and initialize them. Print their values. Algorithm. Import TensorFlow. Define variables with initial values. Initialize variables. Print variable values. How code is working: variables are created and initialized using tf.variable. The initialization is done with tf.global_variables_initializer, and values are printed using TensorFlow sessions. This demonstrates how to work with variables in TensorFlow. Problem 03. Problem statement. Create a computational graph with multiple operations in TensorFlow and visualize the connections between them. Skills required: understanding of TensorFlow's computational graph and basic operations. Instructions. Define multiple operations in a computational graph. Execute and print results. Algorithm. Import TensorFlow. Define multiple operations, example addition, multiplication. Create a session and run the operations. Print the results. How code is working: the code builds a computational graph with addition and multiplication operations. By running the session, the operations are executed, and results are printed. This demonstrates TensorFlow's capability to handle complex computations. Problem 04. Problem statement. Execute a defined computational graph in TensorFlow and retrieve results. Skills required: basic TensorFlow programming and understanding of sessions. Instructions. Define a computational graph. Execute the graph in a TensorFlow session. Print the results. Algorithm. Import TensorFlow. Define a computation graph. Create and run a session. Print the results. How code is working: the code defines a simple computation, addition of two constants, and runs it within a TensorFlow session. The result of the computation is printed, demonstrating how to execute and retrieve results from a computation graph. Problem 05. Problem statement. Use TensorFlow placeholders to feed data into a computation graph and perform operations. Skills required: understanding of TensorFlow placeholders and data feeding. Instructions. Define placeholders in the computation graph. Feed data into the graph during execution. Algorithm. Import TensorFlow. Define placeholders and operations. Feed data using feed_dict during session run. Print the results. How code is working: placeholders are defined to accept input data during session execution. Data is fed into the graph using feed_dict, and the computation result is retrieved and printed. This demonstrates how to dynamically feed data into TensorFlow computations. Problem 06. Problem statement. Save a TensorFlow model to disk and restore it for later use. Skills required: Understanding of TensorFlow's model saving and restoring mechanisms. Instructions. Define and train a model. Save the model to a file. Restore the model from the file. Algorithm. Import TensorFlow. Define and train a model. Save the model using saver.save. Restore the model using saver.restore. How code is working. The code defines a simple linear model, trains it, and saves it to disk using saver.save. To restore the model, saver.restore is used. This process demonstrates how to persist and reload trained models for future use. Section 03. Welcome to our new course, Python TensorFlow Programming with Coding Exercises. In this section, you will learn about linear regression with TensorFlow. In this section, we'll explore how to implement and understand linear regression using TensorFlow, one of the fundamental algorithms in machine learning. Here's what this section includes. Article. You'll start with an article that discusses linear regression with TensorFlow. This article breaks down the concepts and provides practical examples to help you understand the topic thoroughly. If you have any questions or feel uncertain about anything in the article, don't hesitate to message me directly. Assignment. Topic: Implement a linear regression model. Details. The assignment is designed to guide you through the process of implementing a linear regression model in TensorFlow. It includes clear instructions, solution hints, and steps to help you complete it successfully. After finishing the assignment, you can submit it to me for feedback. Coding exercises. Prepare data for linear regression. Learn how to pre-process and prepare your data for training a linear regression model. Define the linear regression model in TensorFlow. Practice setting up the linear regression model within TensorFlow. Compute the loss function. Understand how to define and compute the loss function, a key component of model optimization. Use gradient descent to minimize loss. Implement gradient descent to optimize the model by minimizing the loss function. Train the model and evaluate performance. Train your linear regression model and evaluate its performance on the test data. Visualize the results using Matplotlib. Learn how to visualize your model's predictions and actual data using Matplotlib. A video accompanies these coding exercises, where you'll find detailed explanations of each exercise, including the solution, algorithm, and required skills. After completing this section, you will be able to prepare and pre-process data for linear regression models. Define and implement a linear regression model in TensorFlow. Compute and optimize the loss function using gradient descent. Train and evaluate the performance of your model. Visualize and interpret the results using Matplotlib. If you have any questions, confusion, or problems, please feel free to message me. I'm here to support you every step of the way. Section 03. Problem 01. Problem statement. Generate or load a dataset suitable for performing linear regression. Skills required: basic data manipulation and understanding of linear regression datasets. Instructions. Generate or load data for linear regression. Prepare the data for TensorFlow processing. Algorithm. Import necessary libraries. Create or load dataset. Split data into features, X, and target, Y. How code is working. The code generates synthetic data for linear regression where X is the feature matrix and Y is the target vector. The dataset includes a linear relationship with some added noise, suitable for training a linear regression model. Problem 02. Problem statement. Create a linear regression model using TensorFlow. Skills required: understanding of TensorFlow model definitions and linear regression. Instructions. Define placeholders for input features and target values. Define the model parameters, weights and biases. Define the linear regression model. Algorithm. Import TensorFlow. Define placeholders for X and Y. Initialize weights and biases. Define the linear regression model. How code is working. the code defines a TensorFlow model for linear regression with placeholders for input features and target values. Weights, W, and biases, B, are initialized and the model is defined as a matrix multiplication followed by addition of bias. Problem 03. Problem statement. Calculate the loss function for the linear regression model. Skills required: understanding of loss functions and TensorFlow operations. Instructions. Define the loss function, mean squared error. Compute the loss between the predicted and actual values. Algorithm. Define the loss function using TensorFlow operations. Compute the loss based on the model predictions and actual values. How code is working: the code builds a computational graph with addition and multiplication operations. By running the session, the operations are executed, and results are printed. This demonstrates TensorFlow's capability to handle complex computations. Problem 04. Problem statement. Optimize the model parameters using gradient descent to minimize the loss function. Skills required: understanding of optimization algorithms and TensorFlow's gradient descent. Instructions. Define the optimizer. Specify the learning rate and optimization process. Algorithm. Define an optimizer, example gradient descent optimizer. Apply the optimizer to minimize the loss function. How code is working: the code sets up the gradient descent optimizer to minimize the loss function. tf.train.gradient descent optimizer is used to adjust the model parameters, W and B, based on the computed gradients. Problem 05. Problem statement. Train the linear regression model and evaluate its performance using the training data. Skills required: model training and evaluation in TensorFlow. Instructions. Initialize variables and start a TensorFlow session. Run the training loop and evaluate the model. Algorithm. Initialize TensorFlow variables. Run the training loop. Evaluate the model performance after training. How code is working: the code initializes variables and trains the model over a specified number of epochs. During training, the model parameters are updated to minimize the loss. After training, the final weights and bias are evaluated. Problem 06. Problem statement. Visualize the results of the linear regression model to assess its performance. Skills required: data visualization using Matplotlib. Instructions. Plot the original data points. Plot the fitted regression line. Algorithm. Import Matplotlib. Plot original data and regression line. How code is working: the code uses Matplotlib to plot the original data points and the fitted regression line. It visualizes the linear relationship learned by the model, helping to assess how well the model fits the data. Section 04. Welcome to our new course, Python TensorFlow Programming with Coding Exercises. In this section, you will learn about classification with TensorFlow. In this section, we'll dive into the fundamentals of classification, a key area of machine learning, and how to implement it using TensorFlow. Here's what you can expect. Article. We begin with an article discussing classification with TensorFlow. This article will guide you through the core concepts and provide practical examples to solidify your understanding. If you have any questions or uncertainties while reading, feel free to message me directly. Assignment. Topic: build a simple classification model. Details: this assignment is designed to help you create a basic classification model using TensorFlow. It includes detailed instructions, solution hints, and steps to follow. Once you complete the assignment, you can submit it to me for feedback. Coding exercises. Prepare data for classification. Learn how to pre-process and prepare your dataset for classification tasks. Implement a logistic regression model. Practice building a logistic regression model, one of the simplest yet powerful classification algorithms. Apply the softmax function for multi-class classification. Understand how to use the softmax function to handle multiple classes in your classification model. Compute cross-entropy loss. Learn how to compute cross-entropy loss, which is crucial for training classification models. Train the model and evaluate accuracy. Train your model and assess its accuracy on the test data. Visualize decision boundaries. Explore how to visualize decision boundaries, helping you understand how your model classifies different regions in the data. A video accompanies these coding exercises, providing detailed explanations, solutions, algorithms, and the skills required to complete each task. After completing this section, you will be able to prepare and pre-process data for classification tasks. Implement a logistic regression model in TensorFlow. Apply the softmax function for handling multi-class classification problems. Compute and optimize cross-entropy loss for training your models. Train your classification model and evaluate its performance accurately. Visualize decision boundaries to better understand your model's behavior. If you have any questions, confusion, or problems, please don't hesitate to message me. I'm here to assist you.